Good afternoon everybody. Myself Rupinder Kaur. I am from SRS Government Polytechnic College for Girls, Ludhiana. Today my topic is partial fractions and I will discuss the case when the denominator contains non-repeated linear factors. So, before coming to the topic, I would like to define some terms, and first of all it is polynomial. The expression P naught x n, P 1 x n minus 1, P 2 x n minus 2, so on up to P n, where P i's, that is 0 less than I less than equal to n, are constants n is a positive number is called a polynomial or rational integral function. Of nth degree. That is the highest power of x, that is n, is called degree of this polynomial. Symbols used to represent a polynomial are f(x), phi(x), p(x), q(x), etc. Now, next term is fraction. An expression of the form px upon qx is called a fraction where px and qx are polynomials. Fractions can be of two types. First is improper fraction and second is proper fraction. First of all, proper fraction, if degree of px in the expression px upon qx, that is degree of the numerator, is less than degree of qx, that is degree of the denominator, then it is called a proper fraction. For example, 7x minus 1 upon x square plus 3x plus 2. In this case, degree of the numerator is 1 and degree of denominator is 2. Now next is improper fraction. If degree of px in expression px upon qx is greater than or equal to the degree of qx, then it is called an improper fraction. For example, x square plus 5 upon x square minus 3x plus 2. In this case, degree of numerator is 2, degree of denominator is 2. Therefore, this is proper fraction. Next is x cube plus 1 upon x square plus 5x plus 6. Here the degree of numerator is 3 and degree of denominator is 2, which is greater than. Therefore, this is improper fraction. Now next is partial fractions. When two different fractions are decomposed into one single fraction, then these different fractions are called partial fractions. For example, we have two different fractions and they give us one fraction So these two different fractions are called partial fractions, and this process is called resolving or splitting into partial fractions. Now we will discuss the type. To resolve into partial fractions when the denominator contains only linear non-repeated roots. For example, resolve into partial fractions and given expression is 2x plus 7 upon x minus 1 x plus 2. First of all, we will check that whether this expression is proper or improper. Now clearly degree of numerator is 1 and degree of denominator is 2, therefore it is a proper fraction. Now let 2x plus 7 upon x minus 1, x plus 2 is equal to a upon x minus 1 plus b upon x plus 2. Now taking the LCM in the right hand side and cancelling the denominator, we get a into x plus 2, b into x minus 1 is equal to 2x plus 7. Let this be number 1. Now put one factor, that is x minus 1 is equal to 0. This implies x is equal to 1. So put this value in equation 1. So equation 1 was 2x plus 7 is equal to a x plus 2 b x minus 1. So if we put x is equal to 1, so we get 2 into 1 plus 7 is equal to a 1 plus 2 plus b into 0. So this is 9 is equal to 3a. This implies a is equal to 3. Similarly, put the other factor x plus 2 is equal to 0. This implies x is equal to minus 2. Put this in equation 1. So we get 2 into minus 2 plus 7 is equal to a into 0 plus b minus 2 minus 1. So this is minus 4 plus 7 b into minus 3, that is 3 into b into minus 3. This implies b is equal to minus 1. So we get in this expression a is equal to, here we get a is equal to 3 and b is equal to minus 1. So we have resolved one fraction into two different fractions. So we will discuss another example. Question is 2x plus 7 upon x square minus 3x plus 2. Resolve into partial fractions. Now 2x plus 1 upon x square minus 3x plus 2. Clearly this is a proper fraction. Now first of all we will make the factors of the denominator. Therefore 2x plus 1, this is equal to x minus 1, x minus 2. Now let 2x plus 1 upon x minus 1, x minus 2 is equal to a upon x minus 1 plus b upon x minus 2. Taking the LCM, this is a into x minus 2 plus b into x minus 1 upon x minus 1 x minus 2. Cancelling the denominator in both the sides, we get 2x plus 1 is equal to a into x minus 2 plus b into x minus 1. Let this be number 1. Now we will put one by one, each factor is equal to 0. Now let put x minus 1 is equal to 0. This implies x is equal to 1. So put it equation 1. We get 2 into 1 plus 1 is equal to a, 1 minus 2 plus b into 0. So this is 3 is equal to minus a. This implies a is equal to minus 3. Now again put x minus 2 is equal to 0. This implies x is equal to 2. So we will put this in this equation, that is equation 1. So we get 2 into 2 plus 1, a into 0 plus b 2 minus 1. So this is 5 is equal to b. So we get b is equal to 5 and a is equal to minus 3. Therefore, our required answer is 2x plus 1 upon x minus 1, x minus 2 is equal to minus 3 upon x minus 1 plus 5 upon x minus 2. Now next example, resolve into partial fractions the expression 3x square plus 8 upon 2x minus 5 x plus 2 x minus 1. Now in the denominator we have 3 factors and this is the proper fraction. So we write this as let 3x square plus 8 upon 2x minus 5 x plus 2 x minus 1 is equal to a upon 2x minus 5 b upon x plus 2 plus c upon x minus 1. So taking the LCM on the right hand side and cancelling the denominator on both sides, we get 3x square plus 8 is equal to a x plus 2 x minus 1 b into 2x minus 5 x minus 1 plus c into 2x minus 5 x plus 2. Write it as number 1. Now put each factor is equal to 0, that is put x plus 2 is equal to 0. This implies x is equal to minus 2. Put this value in equation 1, we get 3 minus 2 square plus 8. Now here we have the factor x plus 2, therefore this whole term is 0 and also this whole term is 0. So we are left only with b 2 into minus 2 minus 5 minus 2 minus 1. So this implies 12 plus 8 is equal to b 27. So b is equal to 20 upon 27. So next, put the other factor x minus 1 is equal to 0. We get x is equal to 1. So put this in equation 1. We get 3 1 square plus 8. Now since we have put x minus 1 is equal to 0, therefore this whole term is 0 and this is also 0. So we are left with only c 2 1 minus 5 1 plus 2. So this implies 11 is equal to minus 9c. Therefore c is equal to minus 11 upon 9. In the last, we put 2x minus 5 is equal to 0. So this implies x is equal to 5 by 2. Put it in equation 1. So we get 3 5 upon 2 whole square plus 8 is equal to a 9 by 2 3 by 2. So this is equal to upon 4 is equal to a, that is a is equal to 107 upon 27. So we have a is equal to this value, c is equal to minus 11 upon 9 and b is equal to 20 upon 27. So we get required partial fractions as 3x square plus 8 upon 2x minus 5 x plus 2 x minus 1 is equal to 107 upon 27 2x minus 5. Putting the values of a, b and c minus 11 upon 9 x minus 1. So next example, resolve 6x square minus 20x plus 28 upon 6x square minus 23x plus 20 into partial fractions. Now, since degree of the numerator and degree of the denominator is 2, therefore, this is a improper fraction. Improper fraction. Also 6x square minus 20x plus 28 upon 6x square minus 23x plus 20 is equal to a upon this is equal to making the factors of the denominator that is 2x minus 5 into 3x minus 4. So, in case of improper fractions, we will first divide the numerator by the denominator. In this case, this can be written as 2x minus 5 on the division we get 1 plus a upon 2x minus 5 plus b upon 3x minus 4. Now, taking the LCM and cancelling the denominator in both the sides, we get 6x square minus 20x plus 28 is equal to 2x minus 5, 3x minus 4, that is multiplying by this one into plus a into 3x minus 4 plus b into 2x minus 5, let this be number 1. Now, put the factors is equal to 0, put 2x minus 5 is equal to 0, therefore, x is equal to 5 by 2. Put this value in equation 1, we get 6 5 by 2 whole square minus 20 5 by 2 plus 28. Now, 2x minus 5 is equal to 0, therefore, this term is 0 and this term is 0 and we get only a 3 5 by 2 minus 4. So, this is cancelling this, we get 6 25 by 4 minus 50 plus 28 is equal to a 5 3 15 by 2 minus 4. So, this is 75 upon 2 minus 50 plus 28 is equal to a 15 minus 8 by 2 and this is equal to 75 minus 100 plus 56 is equal to 7a. This implies a is equal to 31 upon 7. Now, put the other factor 3x minus 4 is equal to 0. This implies x is equal to 4 by 3. Put it in equation 1. We get 6 4 by 3 square minus 20 4 by 3 plus 28 is equal to b 2 into 4 by 3 minus 5. So, this is 16 upon 9 minus 80 by 3 plus 28 is equal to B 8 by 3 minus 5.